Okay, let's talk about spanning tree. A spanning tree is the second largest, and it's the most important one for data link for Ethernet. As everybody knows, spanning tree is a loop prevention network protocol, or just a loop prevention protocol. Allows redundancy by creating a loop-free layer 2 topology. That means that if we look at this diagram, we have this triangle, right? Switch connection, interconnection between the three switches. So from a physical link point of view, they have their redundancy because this triangle, but they need to have a protocol to make sure that it is a loop-free layer 2 topology. Why? Because when, for example, when S3, for example, PC4 send out a broadcast, so S1 just forward this to S2, S2 forward this to S3, S3 is forwarded to S1. Just circle around, broadcast is just circle around and just trigger a very big issue. That's why we need, from data link point of view, we need to have a loop-free layer 2 topology. So that means that we have to block one of the interface. For example, right here, S2's interface is blocked. So from topology point of view, they don't have this circle. So just make sure that there's a loop-free topology there. So the spanning tree, we have different types of spanning tree. Spanning tree, we have here we just IEEE spanning tree, which is the L2.1D spanning tree. And every VLAN have its own spanning tree. So this is Cisco proprietary spanning tree. It's called for VLAN spanning tree plus. So that means from every VLAN point of view, there's a loop-free layer 2 topology for every VLAN. There are 4 steps to work out a loop-free topology. And the first step is a elect root bridge. So think about that, let's say that topology. Sometimes if you have opportunity to go on site in the data center, some of the company have very complicated layer 2 diagram. That might be this way, might be this way. There are a lot of loop in among the network in between, a lot of loops, so many loops. So that really depends on the spanning tree to work out the loop-free topology. So the first step for a spanning tree is a elect root bridge. So no matter how big the network is or how small the network is, even just only one switch, they have to elect root bridge. Root bridge kind of like a root or branches, like this is we call a spanning tree. This is the build up a tree. So the root bridge is the root of this tree. This is very important for elect root bridge, kind of like a leader. So how do they elect root bridge? Depending on the lowest bridge ID. So every switches sorry, every switch has a bridge ID, which is unique. So to compare all of the bridge ID, so the root bridge will be elected. For example, here, bridge ID has two parts. It has a MAC-ish, like, and also have priority for the priority. So here is a priority. So when we compare this priority, lowest one is the winner. So this is the one is the winner because priority part is the first part, and the MAC part is the second part. So when you see one of the switches has the lowest priority, that will be a root bridge for this data link for this network. So this one, S1 is a root bridge. Yeah. So how do they achieve this? What I said. So it's just every switch just sends out the BPDU frame. BPDU is just many trip frame. So they change the BPDU. They change the BPDU, and finally they got agreement on this. S1 is root bridge. And the second step is to elect root port. So how do they elect root port? So every switch has one root port. For example, S1 has a root port, S2 has one root port. Every switch has a root port. So this root port will be the shortest or the closest port to the root bridge. For example, in this case, S2, they just elected fast Ethernet 0/1 is the root bridge, this one, because this one is the closest one to the root bridge, which is S1. There's only one hop, right? Only one trunk one or pass one. So this is a closed port to the root bridge. So for S3, they have root bridge here. This is a closed port to the root bridge. This is how we elect the root ports on every switch. By the way, if there's a tooling, what happens? If tooling, kind of like there's a types. So they just choose the lowest port ID. Here is a port ID. Port ID, which is local significant for S3. So every port has this port ID, for example, F01, 0/1, blah, 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 F0/2, blah, blah, blah. This is a different port ID. So 0/1 is the lowest one. So this port will be selected as a root port. This is the one rule for this kind of parallel link. And the third step is to elect designated ports on every segment, on segment. we kind of like have a lot of segment. We have TCP segment. NSS also has segment, but here we call segment is called spanning tree segment or the data link segment. That means the switch a link, this link between the two switch or resides in between two switch. We call this kind of black link is one segment. So for every segment, we have to elect designated port or DP for short, DP designated port. So let's say for S1, for how do we elect designated port? So designated port is from this segment, from the Pacific segment, which port is the closest, which one is closer to the root bridge, which is DP. For example, for this segment, which one is closer one? Definitely this one is a closer one. So this one, because this one is reside on the root bridge itself. So this one is DP for this segment. For this segment, for this black link, this one is DP definitely, absolutely this without a doubt, because this DP. For this link, for this S2, S3 link, which one is closer? That depends. Maybe this, right? Because this symmetric from S1 perspective. This one and this one have same cost, same distance to the root bridge. So by using some other factors, we choose one. For example, by using the S3's BID, bridge ID, or using just compare other factors to elect one designated port. For example, in this case, this one is DP. This one is this link's DP or this segment DP. What about this one? This one, that's a task for the first step. If this one on this segment is elected as a DP, so this port will be blocked. If this one be elected as a DP and this one will be blocked. This is the fourth step to block some of the port. So we can see we have four steps: election of root bridge, election of root port, election of DP specific to every segment. So just be careful for this election, DP's election. And the last step is a block or others. Right? This is AO2.1d triple E spanning tree. How it works. How a spanning tree work out a loop-free protocol topology. So just the election DB, election of the root port, those kind of 4 steps. It just give you just kind of like a touchdown this very simple spanning tree. You can refer to some of the documents about spanning tree, how it works. It's pretty detailed. When we look at the VMware NSS spanning tree, when we talk about spanning tree specifically for NSS, so actually we NSS switch or BSS or BDS, there are different types of VMware virtual switches, but they don't have spanning tree because they use their own algorithm to maintain the loop free.